Yes, A-star search is one of the most popular search algorithms used with heuristic functionality or cost functionality while designing problems or for solution for problems for artificially intelligent systems. To approximate the shortest path in real-life situations like in maps, games where there can be many hindrances, A-star search algorithm proves to be one of the quickest one which can work in the least possible time and provide a solution with the least cost. A-star search algorithm is one of the best and popular techniques used in pathfinding and graph traversal. A-star algorithm is a really smart algorithm. This separates it from other algorithms. A-star is an informed search algorithm or a best first search, meaning that it solves problems by searching among all possible paths to the solution goal for the one that incurs the smallest cost. Previously, we have seen the best first search algorithm, and similar to the best first search algorithm, the A-star search will also consider the cost. And among these paths, it first considers the one that appear to lead most quickly to the solution. So based on our previous experiences, we can add, while designing the problem, we can add certain additional information like a cost functionality to the problem. Like we already know that in this season this particular road will be quicker and this road will have lesser traffic, or based on a distance you can add certain cost functionality, that is the HN, also known as a heuristic. And when you are traveling within the nodes or within the graph itself, you can add a functionality called GN at each node, which is the cost of getting to that node from the start state or the initial state. From the start location to get to any node, there will be a certain cost defined. This is the extra functionality which we are adding in A-star search as compared to the best first search. The priority thus is Fn equal to Gn plus Hn. So the total priority is defined based on two functionality. One is Gn, that is the cost of getting to the node. Gn at a particular node is the cost of getting to the node from the start node, and Hn is the cost of that node. That is, it can be anything in practical case like a distance, or based on our experience of traffic or climatic condition, we can define a certain heuristic for the path. So the A-star will find your best path in very short time provided your H is perfect. So let's consider a simple example, a graph with nodes like A, B, S, C and G, and the cost is defined like from A to S the cost is 1, and S to B the cost is 1, and A to B the cost is 9, and again the G functionality is written on top of each of this node, like it can be 10, 7, 9, 5 and 0 for G. So what will happen is that when you design any problem, the algorithm that will be written based on the A-star will work in this way to find a path from A to G. So the total cost at A is 11 and the total cost at B is 10. That is from while you're traveling from S to A and S to B. While if you're traveling from B to A, if you're traveling from S to B and then you're traveling from B to A, the cost at A is 20. So you'll not consider that. Again, if you're traveling from S to A and from A to B, if you're traveling, the cost is 19. But if you're traveling directly from A to B and B to C and B to G, so that appears to be less cost path if you consider the second step. So in this way you can eliminate those paths in the map or the tree which will be considering more cost. So you will consider only the path which will give you least cost. So again, if you consider, if you're going from B to G, the cost at going from B to G is 13, while the cost of going from C to G is 12. So again you will find that you can ignore, you will not take the path which travels from B to G, while you will take the path which travels from S to B and B to C and from G. And in this way you have found a path. If your S is your start state and G is your goal, then by using the A-star algorithm it will find a path quickly based on the heuristic and the cost functionality which is defined at each node. That's all. If you like this video, please do subscribe, like and comment.